I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we are going to discuss the topic Microstrip Antennas for the course Transmission Lines and Antennas. So, an antenna that is shaped by simply etching out a piece of a conductive material above a dielectric surface is called a microstrip antenna or a patch antenna. On the ground plane of this microstrip antenna, the dielectric material is mounted where this plane supports the entire structure. In addition, the excitation to this antenna can be provided with feed lines that are connected to the patch. Generally, these antennas are considered low profile antennas that are used in microwave frequency applications that we have above 100 MHz frequency. So, the antenna's microstrip or patch can be selected to be rectangular, square, elliptical and circular for ease of analysis and fabrication. Some microstrip antennas do not utilize a dielectric surface, but they made with a metal patch that is mounted on a ground plane with dielectric spacers. Thus, the resulting formation is less strong and its bandwidth is wider. So, if we see the construction, microstrip antenna design can be done with the help of an extremely thin metallic strip by arranging it on a ground plane in between a dielectric material. Here, the dielectric material is a substrate used for separating the strip from the ground plane. Once the antenna is excited, then the generated waves in the dielectric undergo reflections and the energy emitted from the metal patches edges is very low. A microstrip antenna works as whenever current throughout a feed line arrives at the microstrip antenna strip, then electromagnetic waves are produced. So, these waves from the patch will start radiating from the width side. However, when the strip thickness is very small, what happens is the waves produced in the substrate will get reflected through the strip edge. The constant strip structure along the length does not allow radiation emission. The microstrip antenna's low radiating capability allows for covering only wave transmissions with small distance like stores, indoor locations or local offices. So the specifications, its resonant frequency is 1.176 GHz. The frequency range of the microstrip antenna is from 2.26 GHz to 2.38 GHz. The substrate's dielectric constant is 5.9. The dielectric substrate height is 635 micrometer. The feeding method is a microstrip line feed. The last tangent is 0.0012. The conductor is a silver. The thickness of the conductor is 25 micrometer. Its bandwidth is F0 plus or minus 10 GHz, where F0 is the operating frequency. So, and there are several types of microstrip antennas are available. One is microstrip patch antenna, microstrip dipole antenna, printed slot antenna and microwave traveling antenna. So, the microstrip patch antenna, these antennas are low profile antennas where a metal patch is arranged at a ground level through a dielectric material in between comprising a strip or patch antenna. So, these antennas are extremely low size antennas with low radiation. Generally, the patch is made with conducting material like gold or copper. These type of antennas can be formed with the microstrip method by simply fabricating on a PCB. These antennas are used in microwave frequency applications which have greater frequency than 100 MHz. The microstrip dipole antennas is a thin microstrip conductor and is placed on the actual part of the substrate, and it is covered totally with metal on one face known as the ground plane. These antennas are used in digital communication devices like computers and nodes of wireless LAN. The width of this type of antenna is small, so it can be utilized at the entire point of the WLAN system. Printed slot antenna plays a key role in enhancing the antenna's bandwidth with radiation patterns both directions. The antenna sensitivity is low as compared to the normal antennas. These antennas are required throughout a feed line which is arranged reverse to the substrate and vertically to the slot axis provided above the patch. So third type is microstrip traveling wave antenna. So these antennas are mainly designed with a long microstrip line by sufficient width for supporting the TE connectivity. These types of microstrip antennas are designed in such a way that the major beam lines within any route from broadside to end fire. So now the feeding methods, the contacting feed and non-contacting feed. In contacting feed, the power is in contacting feed provided directly to the radiating element. So this can be done with a coaxial line or microstrip. So this type of feeding method is again classified into two types. One is the microstrip feed and another one is coaxial feed. In microstrip feed is a conducting strip with a very small width than the radiating element's width. In non-conducting feed, the power is given to the radiating element from the feed line with electromagnetic coupling. These feed methods are available in three types: aperture coupled, proximity coupled and branch line feed. So the microstrip antenna radiation pattern is broad and it has less radiation power and narrow frequency bandwidth. The microstrip antenna's radiation pattern is shown in the diagram with lesser directivity. By using these antennas, an array can be formed to have a superior directivity. So now assessment: how to improve the bandwidth of microstrip antenna, why do microstrip antennas radiate, how to increase the gain of the microstrip antenna. So we know the microstrip antenna radiates from the width side and its bandwidth can be easily improved by using the arrays, and also the gain can also be increased. Thank you.